Today we are going to learn about solubility rules and the activity series. The activity series is used to determine whether or not a reaction will occur, and the solubility rules are used to determine whether or not a precipitate will form in water. The activity series is a list of elements ranked according to decreasing activity, meaning the top of the list are the most active elements and the bottom of the list are the least active elements. This is the activity series. In the left column, you can see the list of elements ranked by their activity. Lithium at the top has the most activity, and gold at the bottom has the least activity. In the right-hand column, you can see descriptions on how each of the element reacts. From lithium to sodium, the elements react with cold H2O and acids to replace hydrogen. From magnesium to cadmium, they react with acids or steam, but usually not liquid water, to replace hydrogen. From cobalt to lead, the elements react with acids but not water to replace hydrogen. And from hydrogen to mercury, they react with oxygen to form oxides. And finally, from silver to gold, the elements are mostly unreactive. This is a sample question you might see on a worksheet or a test. Will a reaction occur between barium and zinc nitrate? Use the activity series to determine the answer. So, by looking at the activity series, we can see that barium is higher than zinc, which means it is more reactive. So that means in this single replacement reaction, barium will replace zinc to form the product barium nitrate. There is also an activity series for halogens, and it works the same way as the previous activity series, meaning that the elements at the top of the list are more reactive than the elements at the bottom of the list. This is the halogen activity series. Fluorine at the top is the most reactive, and then chlorine, and then oxygen, and then bromine, then iodine, then sulfur, and then phosphorus. Phosphorus is the least reactive halogen. Next up is the solubility rules. Solubility rules are used to show what compounds will dissolve in aqueous solution and what compounds will not dissolve in aqueous solution, meaning that they will form a precipitate. This is useful for determining the precipitate in an aqueous solution composed of multiple compounds. These are the solubility rule tables. In the left picture, you can see elements that cause compounds to be water soluble. In the left column are the ions that cause compounds to be water soluble. In the right column are the exceptions for each of these rules. In the right picture, you can see ions that cause compounds to be water insoluble, meaning they form a precipitate. In the left column are the ions, and in the right column are the exceptions to these rules. First, let's talk about ions that cause compounds to be water soluble. These ions include alkali metal ions like lithium, sodium, or potassium, which means any ions from column 1A of the periodic table. Also, the ions include ammonium ions, acetate ions, and nitrate ions. With no exceptions, these ions cause compounds to be water soluble. In the second part of the water soluble ions of the solubility rule table are halide ions and sulfate ions. These ions have exceptions to the rule, meaning that they don't always cause compounds to be water soluble. For example, when halide ions such as chlorine, bromine, or iodine bond with silver, mercury, or lead, they will form a precipitate in aqueous solution. Sulfate ions will form a precipitate in aqueous solution if they bond with strontium, barium, lead, or mercury. Now let's talk about the part of the solubility rules table that deals with ions that cause compounds to be water insoluble. These ions include carbonate ions, chromate ions, phosphate ions, sulfide ions, and hydroxide ions. The first three ions, carbonate, chromate, and phosphate, all have the same exceptions. These exceptions are alkali metals, which come from the 1A column of the periodic table, and ammonium. These are the ions from the first half of the solubility rules table that had no exceptions. The second part of this half of the solubility rules table include the sulfide ions and the hydroxide ions. These have different exceptions than the first three ions. Sulfide does not form a precipitate when bonded with elements from the 1A column or the 2A column of the periodic table, as well as ammonium. Hydroxide does not form a precipitate when it is bonded with the 1A column of the periodic table, which are the alkali metals, or calcium, strontium, barium, or ammonium. So this is a sample question about the solubility rules table that you might find on a worksheet or a test. So, if a beaker contains lead nitrate and sodium chloride in aqueous solution, will a precipitate form, and if so, what precipitate? So, by reading the solubility rules table, you can see that lead nitrate is water soluble, and so is sodium chloride. But when in aqueous solution, the sodium chloride and the lead nitrate dissociate, and then the lead from the lead nitrate will bond with the chloride from the sodium chloride, which, by reading the solubility rules table, you can see is an exception. So that means that that compound will be a precipitate in the beaker. So, this concludes my video for the solubility rules and activity series. Thank you for watching. Feel free to try the accompanying solubility rules and activity series worksheet. Thank you for watching, and have a good day.